All right, class, today we're going to be covering section 11.4, which is logical implication and equivalence. And the main question that we're trying to answer with this chapter is, with this section, are when are two statements logically equivalent? So here's what we're going to cover, but a little bit out of order because the first thing I do want to talk about are De Morgan's laws. So remember, De Morgan's laws, we talked about in set theory, had to do with unions and intersections. They follow the same rule, except now instead of unions, we have or, and instead of intersections, we have and. So what De Morgan's laws allow us to do is they allow us to negate statements, right? And we know that the negated version is logically equivalent to the original. And I'm going to go through a proof of that and show us what it looks like to be logically equivalent, okay? So when negation is brought from outside the parentheses to inside, it flips the connective from an and to an or an or to an and, okay? So let's go ahead and make some truth tables to prove De Morgan's laws and show that they are logically equivalent and get a gut feeling for what logically equivalent means. So here I have my truth table, and I'm trying to prove De Morgan's laws. So in order for something to be logically equivalent, the truth tables for both of these need to be the same. So let's go ahead and fill in our truth table. I've got true, true, false, false, true, false, true, false. I need not P. Well, if P was true, then not P is false, false, true, true, false, true, false, true. So I need not P and Q. So remember, P and Q, this is P or Q. P or Q is true if P or Q is true, okay? So true and true would be P or Q is true, but I want not P or Q, and that would be a false. So I've got P or Q, that'd be true, because I've got P or Q, but I have not P or Q, so that would be false. Again, I have P or Q, that would have been true, but I have a negation of that, so I get false. And then I have false or false, which would give me a false, but I'm looking for the negation of that, which is true. And I need to see if this column is logically equivalent to not P and not Q. That means I'm going to have the same truth values. So let's take a look at not P and not Q. Remember that and is only true if I have both of my connectives are true. So if I have false and false, that's false. False and true, that's false. True and false, that's false. And true and true, that's true. Because both of these columns, right, right here, have the same truth values of false, 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 true, we would say that these are logically equivalent. Okay, and thus we proved De Morgan's laws are logically equivalent. Let's work through the other De Morgan's law. So the other De Morgan's law is not P and Q. It logically implies not P or not Q. So let's go ahead and fill in our truth table. Not P would be false, false, true, true. Not Q would be false, true, false, true. Let's look at P and Q. Remember, P and Q is only true if both values are true, but then I'm taking the negation of that. So here I have true and true. That would be true, but it's the negation, so false. Here I have true and false. That would be false, but it's the negation of that, so I have true. False and false, that would be false, but the negation of that makes it true. And false, that would also be false, but the negation of that makes it true. Wonderful. I need to see if this is logically equivalent to not P or not Q. Remember, for or, I'm sure I've said this a bunch, I just need one of my values to be true. So false and false would give me a false, but false and true would give me a true. True and false would give me a true, and true would also give me a true. So because these two columns are the same, They are logically equivalent. Now, we can also apply De Morgan's laws to a sentence. So if I want to, I can do that to negate the sentence. So here I have, there is water on Mars and Pluto is a planet. I don't know if you caught it, but Pluto is not a planet anymore. Super bummed. Let's represent it with there's water on Mars. We'll let that be P. And Pluto is a planet, that could be Q. So I have P and Q. So if I negate P and Q, right, then I would have not P or not Q using De Morgan's laws. So I would have, there is no water on Mars. Right, that's not P. Or Pluto is not a planet. So we can also negate the sentence. It is false that Jack and Jill went up the hill. So it's false that P and Q, right? It's false that Jack and Jill went up the hill. So that means I would get Jack did not go up the hill or Jill did not go up the hill. If I wanted to say this not in symbols anymore, but translate it to a normal sentence. And these make sense, right? Because De Morgan's laws are an example of logical equivalence. Now, what does it mean for something to be logically equivalent? So, two statement forms that have the same truth tables would be called logically equivalent. We then would write this double arrow symbol right here. A statement that has a truth value regardless, a truth value of true regardless of the value of its component statements is a tautology. And we denote that with the letter T. We talked about this in the last section. And the same as a statement that has a truth value of false regardless of the truth values of its component statements is called a contradiction, and we denote it with the letter C.